Hello students, welcome to the Toppers Tool community. I am Mr. Prakash Chogle, lecturer in mathematics. In this session, we will be learning Laplace Transform. So Laplace Transform is a very interesting tool that used to solve the differential equations that arise in the engineering problems. So it is named after famous mathematician Pere Laplace. Okay. So what actually Laplace transform is? As the name itself stands, transform. It transforms function of one variable into function of another variable. So especially the time parameter is converted into frequency parameter. So you learn or you use this when you go for or studying some engineering applications like signals transmission and so on. So my intention is to introduce you Laplace transform as possible as easy. Okay, so Laplace transforms, as I said, function of t into function of some other parameter s. So it is defined as, basic definition of Laplace transform is, better you note down. So if f of t is real valued function, if f of t is real valued function means its a domain and range both used to be subsets of real numbers. If f of t is real valued function and the parameter or the variable t is greater than or equals to 0, then only this can be defined. Then Laplace transform of f of t is denoted by L of f of t, and it is defined as L of f of t is equal to, basically it is an integral operator, definite integral. So 0 to infinity, integration 0 to infinity e power minus st f of t dt. So when you apply this integral to f of t, it gets transformed into function of s. So basically Laplace transform transforms function of t into function of s. So therefore we write L of f of t is equal to f bar s, because this gets transformed into function of s. When you integrate and apply the limits 0 to infinity, this function turns into function of s, transformed into function of s. So that is why we write L of f of t as f bar s, or in some text you find capital F of s. Okay, so Laplace transform of any function gets transformed into function of s. This you have to remember, and rest of the thing is very simple. So let's understand Laplace transform of some common functions, because those are very much essential. Okay, now we will be dealing with Laplace transform of common functions that you have to remember throughout the chapter. So Laplace transform of, go on writing Laplace transform of some elementary or common functions. Like how you find remember derivatives of standard functions, in the same way you have to remember the Laplace transform of some common functions. Okay, so Laplace transform of any constant a, Laplace transform of constant a is a by s. I will be proving it where a is constant, where a is constant and s is greater than 0. S has to be greater than 0. Laplace transform of e power at is 1 by s minus a. Go on writing. I will be proving it in the next section. Laplace transform of e power minus at is 1 by s plus a. Okay, so in this case s has to be greater than a, otherwise it becomes infinity. Laplace transform of sine at is a by s square plus a square. Laplace transform of cos at is s by s square plus a square. Remember this. Laplace transform of sine hyperbolic at is a by s square minus a square. Few more. Laplace transform of cos hyperbolic at is s by s square minus a square. Laplace transform of t power n is n factorial by s power n plus 1 if n is positive integer. If n belongs to z, n is a positive integer. Otherwise, we can have also alternate formula. If it is not an integer, it is gamma. It is gamma. We write it as gamma n plus 1 by s power n plus 1. If n is something 1 by 2, so on. Okay. So if n is not an integer, positive integer, we go for this L of t power n as this. So these are the few things to be remembered throughout this chapter, where n is constant here, where n is constant. Okay, so you have to remember this, and I will be proving these. Okay, so let's have proof for this. So first one, as I mentioned, Laplace transform of a is a by s. Let's prove this. Okay, as we know that by the definition of Laplace transform, what L of f of t stands for? Laplace transform of f of t is defined as integration 0 to infinity e power minus st f of t dt. This is the definition for Laplace transform. Okay, we are interested in Laplace transform of constant function. So I put f of t is a. So L of a is 0 to infinity e power minus st into f of t as a. Okay. So a is a constant here. 0 to infinity e power minus st dt. And you know the integration of, remember this, if you don't know, integration of a power x with respect to x is e power ax by a. Okay, so use that. A into integration of e power minus st is e power minus st by minus, yes, the coefficient of t is minus here, yes. Okay. And the limits 0 to infinity. Okay, so wherever t you have to put infinity and 0. Okay, so you have to put t is equal to 0 and infinity. As you know, first you have to substitute upper limit. So a into, okay, wherever t you substitute infinity first, e power, if you replace t as infinity, it's multiplied by minus, so it becomes minus infinity, e power minus infinity minus e power 0 divided by minus s. Okay, this implies e power minus infinity is 0, e power 0 is 1 divided by minus s. Look at this, because e power minus infinity can be written as 1 by e power infinity, 1 by e power infinity is infinity, 1 by infinity is 0, and e power 0 is 1. Please note these values. We often come this e power minus infinity, so you have to replace it as 0. Okay, so minus minus cancels, you left with a by yes. So a by yes. So this is your Laplace transform of a. Okay, so I hope you understood this. Okay, likewise we will be doing few more. So if you are new to my channel, then please do subscribe and share with your friends, so as to bring you many more things of this applied mathematics. Okay, let's have second one. L of e power at as 1 by s minus a, where s is, or s has to be greater than a. Okay, again use Laplace transform definition. So we know L of f of t is equal to integration 0 to infinity e power minus st f of t dt. So replace, you want L of e power at, so I replace f of t as e power at. It is 0 to infinity e power minus st, f of t I had to replace e power at, and this dt as it is, very simple. 0 to infinity, by the law of indices, I can keep this common base as e, and it is minus st plus at dt. Okay, you know this. a power m plus a into, sorry, a power m into a power n can be written as a power m plus n. So likewise you have a common base here. So power to be added, e power minus st plus at. So 0 to infinity, I take minus s, that's minus t common. So minus common and t common. So what will left with? S minus a dt. Okay, I have taken minus common and t common. So you left with s minus a. Now think of or remember this. What is integration of e power ax with respect to x? Integration of e power ax is e power ax by a. So this you have to remember. Okay, so using this, your a means this minus s minus a. So I can write it as 1 divided by, sorry, e power minus of s minus a into t divided by, here a means minus of s minus a, and the limits 0 to infinity. Okay. Now substitute upper limit wherever t you have to put these limits. Okay. So you have to put t is equal to 0 and t is equal to infinity. So if you put t is equal to infinity here, so this becomes minus infinity. So e power minus infinity minus e power, if you put t equal to 0, you will get 0 divided by minus of s minus a. Okay. So as I mentioned earlier, e power minus infinity is 0, e power 0 is 1 divided by minus of s minus a. Okay. So which is nothing but 1 by s minus a. This is your L of e power at. Remember this. And for example, we come across this. Suppose if you require Laplace transform of e power 3t, so you can write directly it is 1 by s minus 3. Okay, here a is 3. Similarly, L of e power 7t is 1 by s minus 7. Okay, like this you have to use. And suppose if it is negative, then just note this. Okay, if you replace a as minus a, so it becomes plus a. So you have to remember this L of e power minus at as 1 by s plus a. Okay. So suppose if you get like this, Laplace transform of e power minus 2t, then you have to write 1 by s plus 2. Suppose Laplace transform of e power minus t, 1 by s plus 1. So like this you can use the Laplace transform of e power at and e power minus at. Okay, so now we will have Laplace transform of sine. Okay. So third one, L of sine 80 is a by s square plus a square. Okay. Again, you have to use the Laplace transform definition. So we know that L of f of t is 0 to infinity e power minus st f of t dt. Okay, so this is we know. Now you have to replace f of t by sine 80, so which implies L of sine 80 is 0 to infinity e power minus st and f of t as sine 80. Okay, so we are replacing f of t by sine 80. Okay, now we need to integrate this, and there is a one common formula. You have to remember that. Note down this. Please note down this. Integration of e power ax into sine bx. Integration of the product of e power ax and sine bx is e power ax by a square plus b square into a sine bx minus b cos bx. Please remember this. Okay, so using this, here a means what? Here a means minus s and b means a. Okay, so here your a is minus s and b is a. So carefully, so e power ax means e power minus st divided by a square plus b square. So square of these two will get s square plus a square. S square plus a square will get into a sine bx. Here t is the variable. A means minus s sine 80 minus b means a. It is a cos bt, and the limits you are solving this, evaluating definite integral between 0 and infinity. So you have to write 0 and infinity. Okay, remember, please remember this formula. Without that, it is impossible to evaluate. Okay. Now, if you apply the limit 0 and infinity, okay, so when you replace t as infinity, actually it turns into infinity by infinity form, and which when you evaluate by L'Hospital's rule, you will get first term as 0. So after substituting upper limit e power, that is t as infinity, so this turns into e power minus infinity, and this is infinity. So infinity by infinity will get, and on evaluating you will get 0. So please remember this, first term becomes 0 when you apply the limits. Second one you supply 0. So what you will get? E power 0 by s square plus a square minus s into, if you apply 0 here, sine 0 is 0, so this term becomes 0, minus a into, if you supply t as 0, cos 0 is 1. Okay, so this term you have to remember. After applying the limits, it becomes infinity by infinity, So on evaluating you will get 0. Okay. Now this term e power 0 is 1 by s square plus a square. This is 0 minus a. So this gives you a divided by s square plus a square. So this is your L of sine 80. Please do remember. Laplace transform of sine 80 is a by s square plus a square. Okay. Now how it can be used or helpful? So Laplace transform of sine, suppose 3t. So Laplace transform of sine 3t can be written as 3 by s square plus 3 square, that is 3 by s square plus 9. Suppose if you come across sine of 90, L of sine of Laplace transform of sine of 90, you can write it as 9 by s square plus 9 square. So one can write directly it's a 9 by s square plus 81. Okay. Now we will have Laplace transform of cos. So Laplace transform of cos 80 is s by s square plus a square. Okay. So by the definition, of Laplace transform, Laplace transform of cos 80. Okay. How will you write? It is 0 to infinity e power minus st into cos 80. Instead of f of t, you have to write cos 80. Okay. Now you have to use again one integral formula. So use this integration a power ax into cos bx with respect to x, that you have studied in 12th standard. Okay. So integration of this is, as earlier, it is e power ax by a square plus b square into a cos bx plus you will get b sine bx. Do remember this. Okay. So e power ax by a square plus b square, a cos bx plus b sine bx. Okay. So here what a and b stands for? Here a stands for, as earlier, minus s, and b stands for a. Look at this. Coefficient of t here is your a and this is your b. Okay. And t is the variable. Instead of x we have t here. So please use this. Okay. How much you will get? E power minus st divided by s square plus a square, as earlier. If you square and add this, you will get s square plus a square into minus s cos 80. Look at this. Here a is minus s plus b means a sine 80, and the limits 0 to infinity. Okay. Now, as I mentioned earlier, when you put this upper limit here, here and here, e power minus infinity is 1 by e power infinity is infinity, so this turns into infinity by infinity, and when you evaluate it by indeterminate form, it gets 0. So I directly write 0 as a first, and now you can supply this upper lower limit. So e power 0 by s square plus a square minus s into cos 0 is 1 plus a into sine 0 is 0. So minus into minus plus, e power 0 is 1, so you will get s by s square plus a square. So this is your Laplace transform of cos at. So please remember, Laplace transform of sine is a by s square plus a square. Laplace transform of cos is s by s square plus a square. For examples here, L of cos 70 can be written as 7 by s square plus 7 square. L of cos 3t, sorry, I had gone wrong here, please, s by, it is s by s square plus 7 square. L of cos 3t is s by s square plus 3 square. Okay. Similarly, we will be having for hyperbolic. Let's do those. L of sine hyperbolic at as a by s square minus a square. So here easily it can be proved without using basic definition of Laplace transform. Okay. So as we know that sine hyperbolic at can be defined as e power at minus e power minus at by 2. This is the definition or exponential form of this hyperbolic, sine hyperbolic. Now take 1 by 2 common. So L of e power at minus L e power minus at. Now you know the Laplace transform of e power at, just apply that. What is Laplace transform of e power at? It's 1 by s minus a. Laplace transform of e power minus at is, as I mentioned earlier, it is 1 by s plus a. Very simple. Just take LCM. S plus a into 1 s plus a minus, if you multiply this side, minus a, this minus into minus a, that becomes plus a, divided by s minus a into s plus a. Okay. 1 by 2, your ss cancels, a 2a divided by, this of the form a plus b, a minus b, you will get a square minus b square. Like that you will get s square minus a square. Okay, do remember this, I hope. A plus b into a minus b is a square minus b square. Okay, we have used that. So 2 cancels. Okay, 2 to cancels. So a by s square minus a square. So this is Laplace transform of sine hyperbolic at. So similarly, we will have cos hyperbolic. Let's L of cos hyperbolic at is s by s square minus a square. Okay. Let's prove this. So L of cos hyperbolic at. So cos hyperbolic at can be expressed in terms of exponential form in this form. Please do remember this. Here you'll get plus. Okay. So this is nothing but it is exponential form of this hyperbolic functions. So 1 by 2 outside, L of e power at plus e power minus at. So which is equals to 1 by 2 into Laplace transform of e power at. It's a 1 by s minus a. And Laplace transform of e power minus at is, it is 1 by s plus a. So which is equals to 1 by 2. Take LCM. As this. So you have to multiply this to this. It becomes s plus a. And here it's plus. So this remains as it is s minus a. Now here a cancels. What remains is 1 by 2 into 2s by, okay, this is the form a plus b, a minus b, a square minus b square as earlier. Okay, 2 cancels. So you're left with s by s square minus a square. This is Laplace transform of cos hyperbolic at. Okay, so 2 more. If you want some examples, Laplace transform of sine hyperbolic 60 can be written as 6 by s square minus 6 square. Okay, a by s square minus a square. L of cos hyperbolic 2t is s by s square minus 2 square. So this is how you can find Laplace transform of some common functions. So in the next session we will be doing Laplace transform of t power n. So keep watching and keep subscribing and please share with your friends. So we'll meet in the next session. Till then, take care.